Hello and welcome to part 2 of lesson number 3 in Unit 2 Quadratic Functions, Forms, and Transformations in our grade 11 University College Math class. This is Transformations part 2. We've looked in the first half, or in the first part of this video, we looked at horizontal translations and we saw that those are linked to whatever's happening inside this bracket here, specifically what our h value is. Now again, recall that our h value, because there's a negative inside this bracket, our h value, if positive, will actually look negative and will be a horizontal translation h units to the right. If it's a negative value for h, it's actually going to be x minus h, which is going to look like a positive value despite being a negative value, which means that we are going to be horizontally translating h units to the left. So that was horizontal translations, the first part of this video. Second part, we're going to look at vertical translations. So now we're going to be looking at specifically what this k here does at the end. What's the k up to? So once again, we've got some graphs here to set up. Let's get some highlighters happening here. So we are going to do the parent function again, y equals x squared. That's a nice point of comparison. Then we're going to do x squared plus 5 as our second graph. And lastly, we are going to do y equals x squared minus 10. So we have three graphs. Let's get started. Parent function, of course, by this point now, we know that it goes through 0, 0. It goes out 1, up 1 in both directions, and out 2 and up 4, out 3, up 9, etc. Whatever the input value is, we square it. We can skip over the domain this time because we know the domain is going to be wide open for all of our theoretical parabolas. The range, however, is a little bit different. The range is limited by the highest or lowest point that our parabola reaches. In this case, 0 is the lowest point, so the set of all y's such that y is an element of real numbers, where y, 0 is our lowest point, and because our parabola opens up, it'll be greater than or equal to 0. Let's pop that on the graph real quick. And I know this is time consuming, but this is really good practice for when we get to the sketching. And we're going to do some sketching in Unit 2A and way more sketching in Unit 2B. So it's good to get this under control. Practice it up a little bit. So from the vertex out 1 and up 1, back to the vertex out 2 and up 4. There we have our parent function. So make it a little bit curvy. Let's get some arrows on there. And as before, because we're going to be sketching 3 of these, we're going to hold off on our labeling just for now, just to make sure we have space to do what we want to do. Okay, second example now is x squared plus 5. So when we are doing our substitution, which again I'm going to do mostly in my head here, but just to sort of show you what we're up to. Again, I've picked the y values we're going to be inputting here. Any y value will work. It's just about which ones are going to legitimately show up on the graph. So I've picked some, again, clustered around the origin that will work nicely. So if we substitute -2 in there, that's going to be -2 squared, which gives us 4, and 4 plus 5 gives us 9. If we were to substitute in -1, -1 squared gives us 1, plus 5 gives us 6. If we were to, still going to stick with this color, if we were to substitute 0, 0 squared, of course, is 0, plus 5 gives us 5. And just to save us a little bit of time, this pattern will continue. So what does this graph look like? Let's put it on there. So we have -2, 9. So -2 9's up here. -1, 6. 0, 5, 1, 7, and 2, 9 again. So let's get some lines in that. There we go. Keep it a bit curvy. Get the arrows on there. So our lowest point that we can see is going to be our vertex, and our vertex then is going to be 0, 5. I realize that we did not label this in our parent function. Of course, the vertex is going to be 0, 0. There we go. And let's get back to looking at our range. So the range, again, let's set it up first. Set of all y such that y is an element of real numbers. We know there will be a limit on the range where y, so what's our lowest point going to be here? Our lowest point, if we're looking at the graph, it has a height of 5. So that means our lowest point has a y value equal to 5. So that will be our limit. Our parabola opens up, so that will be greater than or equal to 5. That's how we set up our range. So if we look at that, we'll see that just visually we can see that it's the same graph except between the parent function and the one we've just graphed, except that it's 5 units higher than that. Let's have a look at example 3. Again, if we were to insert or substitute number -2 in here, minus 10. So negative 2 squared gives us 4, and 4 minus 10 gives us negative 6. If we were to substitute in negative 1, whoops, that's a highlighter. Substitute in negative 1, we'd have negative 1 squared gives us 1, minus 10 gives us minus 9. If we substitute a 0 in there, 0 minus 10 gives us minus 10, and the pattern is going to continue. So let's get this on the graph. So we have at negative 2, we have negative 6, that's right here. At negative 1, we have negative 9. At 0, we have negative 10. At 1, we have negative 9. And at 2, we have negative 6. Let's sketch it out, keeping it curvy. Get some arrows on there. There we go. Now we can put some labels onto our x and y intercepts. So this one here is at 0, negative 10. And our parent function, of course, 0, 0 is our vertex. And for the second example, we had a vertex of 0, 5. Kind of squish it in. There we go. So our vertex, of course, is our lowest point in that third parabola. The lowest point is negative 10. And our range, of course, set of all y, such that y is an element of real numbers, where y, now our low value is negative 10, and because our parabola opens up greater than or equal to negative 10. So there you have it. What hopefully you've noticed is that this last value, this constant value, it's going to indicate exactly where the y component of the vertex shows up. If you need a little bit of an extra prop here, this could just as well be x squared plus 0 in the same way this was x squared plus 5 or x squared minus 10. So again, I want to make sure that we're seeing that. The plus k, which I guess is a plus or minus k at the end, that's going to speak to the y component of the vertex. Y component of the vertex. In the same way that when we were working with our horizontal translations, again, this one might well be written y equals x plus 0 all squared, and they'd never write that because that's wasteful. You don't need to. But this 0 here corresponds to the y component of our vertex. Recall that that's the opposite of how it appears. Looks like a plus 7 is actually a minus 7. So these two sets of translations, both horizontal and vertical, correspond to the horizontal and vertical translations you're making to a parabola in vertex form. So let's do a little summary. Summary says the graph of f at x equals x squared plus k. This is a vertical translation. And that means that we are going to translate k units in the up direction because our k value being positive, we take that at face value. So positive value, of course, sends you up the y-axis, and negative value, of course, sends you down the y-axis. So y equals x squared minus k. This is also a vertical translation of k units. Of course, the difference being that this time our parabola is going to open down. Now, what if we don't have a k value, or I guess more accurately, what if your k value is equal to 0? Do we have that on? Oh, we don't even have that on here. Okay, I'm going to add that. So when our k value is greater than 0, our graph moves upward, is translated upward. When our k value is negative, our graph moves downward. And I want us to add here, when k equals 0, vertex is on the x-axis. Doesn't move up or down, and again we can see that in the parent function. It's sitting right there on the x-axis. So there you go. That is vertical and horizontal translations. The rest of the lesson is just some examples. I think we'll have a chance to squeeze one out here, and then we'll tackle the next 3 in part 3. So let's see if we can get part 1 here finished up. So we're going to describe how the graphs of the following functions can be obtained from the graph of the function y equals f at x. So what this is really just saying is what translations have been made to these graphs we've been, or these equations that we've been given based on a starting point of our parent function. So if we have y equals x squared plus 8, we recognize that because this is a constant value sitting at the end, it's not inside the brackets. So the ones outside the brackets are vertical. This is a vertical translation, and again, these words are important. We want to make sure that we have the terminology to discuss this properly so everybody understands. This is a vertical translation. Now this is a positive 8, which means that we will be going up, and in this case 8 units. So a vertical translation up 8 units or 8 units up, that is our first one. Our second one, we have a translation happening inside the bracket. This, of course, is a horizontal translation. And a horizontal translation obviously moves us left and right. In which direction are we going here? Well, this looks like a -4, but this is actually x minus +4, because those two signs beside each other with no number in between, we would condense that down to a single sign being negative, even though it's a +4. So that means this is going to be a horizontal translation. How many units was that? 4 units to the, units to the right, since it is actually a positive value. Looks like a negative is a positive. So for these last two, I'm going to use some short forms. Typically, I would say on assessments and things like that, knowing the proper terminology, it needs to be demonstrated once. Otherwise, you can use some shortcuts to save yourself some time. So we have two different translations or transformations happening here. We have this one and we have this one. The first one, of course, as we read left to right, is a horizontal translation. That's going to be 2 units. And again, it looks like a negative, is in fact a positive. So that means we're going to be shifting 2 units to the right. The last one is a vertical translation. It's a -5, so that'll be a vertical translation 5 units down. Right on. And last but not least, x plus 1 all squared minus 12. So as we read left to right, our first transformation is a horizontal translation. 1 unit looks like a positive, is in fact a negative. So that will be 1 unit to the left, which again, if we consider here, negative values head to the left, positive values head to the right, just for a reference. And our second transformation is a vertical translation, so that's 12 units, and it's negative, so that will be 12 units down. And that is our first example. When you come back for part 3, we're going to finish this up by doing a few more examples, just ways that we can apply what we've learned about horizontal translations. So we'll see you in part 3.